Hey guys, my name is Jani.
And my name is Murat.
And this guy here is Buddy. And Buddy has been working really hard over the weekends, throughout the nights, bringing measurement results for us. In this video, we will tell you the results that Buddy has now measured. We will also explain a little bit how Buddy works. And then in the end of the video, we will go a little bit deeper into the measurement results, how we did the measurements, but we are not going to go too deep because we have a webinar coming up. Please sign up for the webinar, and then you can ask all the questions from our engineers how we actually do all these measurements. But without further ado, Murat, which devices did we test?
Yeah, so for this benchmark study we tested, in addition to Apple Vision Pro, we tested also MetaQuest Pro, MetaQuest 3 and HTC Vive XR Elite.
Okay, and then what is common denominator for these devices? They all support pass-through.
That is correct, yes.
Okay, so that's why they are good to compare against each other. So, what is the first measurement that we did?
So the first measurement we did was see-through photon-to-photon latency. And in this category, Apple Vision Pro is definitely the category leader because they were announcing that their see-through latency was going to be 12 milliseconds, and now what we found out was actually even lower than that, 11 milliseconds. When you compare these results with all other devices that we tested, they were in the range of 35 to 40 milliseconds. So they definitely did something magical here, and then they definitely improved these benchmark metrics, so that now this is the new set for this category.
So basically Apple now set the bar for the other devices, and then 11 milliseconds is so short time that you can basically use this for your everyday activities and it wouldn't bother you too much. And then we have already seen in many of these YouTube videos and Instagram videos and TikTok videos where people are actually using Apple Vision Pro in, for example, driving a car, but I would not propose to do that though. Okay, and then what is the next result?
And the next result is angular motion to photon latency, and in this category both MetaQuest Pro, MetaQuest 3 and Apple Vision Pro reported minus values between -1 to -2, and then HTC Vive XR Elite reported +4 milliseconds.
Okay, so then of course people might wonder, like, how is it possible to get minus latencies? So one of the reasons for that might be that the device is, for example, over predicting. So when you are moving it, it basically moves the image a little bit too far ahead, and that would give a wrong value. But also it depends on how you define the latency. But yeah, we might go a little bit deeper on that next, and then also you guys can ask more questions about our engineers in the webinar. So how about the last result then?
And the last result was angular jitter during the movement, and in this category MetaQuest 3 reported the best values, and then the worst values were with the MetaQuest Pro, and then the Apple Vision Pro results were in the mediocre level.
Okay, so then in this one Apple didn't actually set the bar, it was more like a mediocre
That is
thing.
correct.
Yeah.
That is correct.
Yeah, and I think that I have actually seen that when I have used the device that sometimes the image kind of shakes a little bit, so it doesn't exactly stay where it is supposed to stay.
Yeah,
so,
that's true.
So I think it's visible. Okay, so I think we will now give a little break for Buddy here, and then we will talk about how Buddy works internally. Okay, so Buddy took a little break, and we will show you guys how Buddy works. So Buddy has 2 cameras here, and then behind the cameras we have tri-stimulus sensors. The tri-stimulus sensor works with the 100 kilohertz frequency, and then the camera's maximum frequency is 120 hertz. And that way we can capture every frame from the device for analysis purposes. You can adjust the distance of the cameras and also the distance to the device, so that way you can set it up to match your own device. Buddy has different kinds of head pieces, so this is just a normal human head which you can basically mount any device on it. And then the robot has encoders on every axis, so then we know exactly what position the robot was in any moment. And all these signals, so the signal that comes from the camera, the tri-stimulus sensor, also from the encoders, all of that is set to the same timeline. So when we compare the numbers, we know exactly when things happened.
And on the device side, so we are utilizing a method called absolute tracking. In order to do that, so we are running our own application on the HMDs. This could be based on Unity base or OpenXR or CloudXR, for example. So we have these constellation markers, and these are giving us the position in the virtual environment.
Okay, and then when we get the position from the virtual environment, we can basically compare that position to the position of the robot from the encoders. And that way we can make most of the measurements with BUDDY.
Yes,
and
sure.
then how about the optional items? What can you buy and buy more to BUDDY?
Yeah, so as we have already reported see-through latency, so see-through latency requires an external LED target that is going to be in front of the HMD here. So that is something that we can do as an optional item. And also we can also control and measure and characterize the latency performance of the hand controllers, which requires additional head also here.
Okay, so controller measurement and then measuring the pass-through latency.
Yeah, that's true.
Okay. Cool. So now you guys have understanding on how BUDDY works, and then as I said in the webinar, you guys can ask more questions. Let's dive deeper into the results. So how did we do the measurements? Let's start with the photon-to-photon latency again.
Yeah, so photon-to-photon latency, also called see-through latency. So Apple Vision Pro is a video pass-through device, and then there are 4 high-resolution cameras here, so they are capturing the real-world content and they are displaying those content to the user's eyes through the display.
Okay, and then of course then there's a latency from the capturing to seeing the image, and then how we measure it here in OptoFidelity, we have this dome light in front of the device, which will basically show light into the cameras. We have a LED that illuminates the dome, and then we can see the light on the display after you have illuminated dome. So basically the time between the illumination and then the time that we detect the light on the other side, that is the latency. And then the sampling rate on the other side here is 100 kilohertz. So we will get really precise measurements when we actually see the image change in the display.
Yes.
Yeah, so that way we can get precise measurements of the photon-to-photon latency. So then how about then the motion to photon?
Yeah, so motion to photon latency is really important parameter when it comes to testing the immersive experience of any type of HMDs. So in its essence, it means when you are moving your head, the virtual content also needs to move to the same rate, so that when there's a disparity, the time difference between these movements and your actual physical movement, that is called the motion to photon latency.
And then just, when we just showed you guys BUDDY, we told you about the application that we are running on the device. So basically the application has those markers in there, and then based on the markers we know exactly where we are looking at in the virtual environment, and then we can compare the position to the robot's encoder positions, and that way we know exactly what is the latency between the movement and then the virtual response.
Right.
Okay, and then how about the jitter?
Yeah, so jitter can be also defined as inconsistencies in the latency. They are usually experienced as shaking of the image or the sudden jumps in the image, different frames. So they are also impacting your immersive experience. So they're also causing a dizziness, motion sickness.
And then basically in the BUDDY, you will basically kind of do this motion to photon latency measurement, but then you subtract the robot motion from the virtual content motion, which will basically normalize the motion signal into one line, and then we can analyze it with the certain size of a moving window, that what is the maximum like peaks and the valleys of that signal, and that is then the jitter.
That's true.
Yeah. So yeah, this is how we do it. We didn't want to go too much in the details because we do have that webinar coming up. So please guys, sign up for the webinar. You can ask all the questions from our engineers and they will go into more depth with these numbers. Thank you guys for watching. We will see you in the next episode.
Thank you.